welcome everybody, and hopefully we get a few more people joining in. This is our next AIoT Canada webinar. Our speaker today is Umair Sadiq. He'll be talking about safety assurance of AI-based systems. Really look forward to his presentation, but before we get going, I just want to talk about some of the guidelines in the webinar. Nothing too onerous. The decorum is very simple. Just stay muted during the presentation. You can have your camera on or off. It's up to you. If you do have a question during the presentation, pose it in the chat window, and would appreciate it if you preceded with the word question so we can tell the difference between a question to the speaker and chat that you have with other attendees. So do feel free to just chat amongst each other about the topic or introduce yourself at will. A little bit about AIoT Canada. For those of you who may not be aware of what we are, AIoT Canada is an industry association representing the Canadian ecosystem of providers and adopters of products based on the fusion of artificial intelligence and IoT. Together, they form this new paradigm called AIoT. And we also include investors, policymakers, and academia. The association brings members together to connect, interact, and learn from each other. And the whole point is to amplify their market growth and operational effectiveness, influence national policies, reduce business and innovation and societal risks, advance international reach, and overall generally contribute to the Canadian economic growth. Now, who do we serve? Our members are providers of AIoT products and services, adopters of AIoT, independent innovators and thinkers, academia, policymakers, investors, and accelerators, and there is a contingent of professional service providers like consultants, lawyers, accountants, legals, etc., that are involved in this space. And we do that by providing newsletters about the industry, webinars like this. We do facilitate access to education and training programs, although we don't create or deliver those courses ourselves. We also provide opportunities for networking, in-person networking, and we hold an annual AIoT Summit. And this year, the AIoT Summit will be held on May 27th here in Ottawa. We also form partnerships and collaborations with a variety of other related organizations like IEEE, CMC, Smart City Association, and so on. And the point there is to cross-pollinate each other's members on the topic of IoT and AI. We have formed an experts panel, which enables our members to access expert advice formed from among our other members or actually independent influencers and thought leaders in the industry. Our forthcoming projects, or something that's in flight but not quite there yet, is an industry mapping project. The objective there is to compile, categorize, and organize information about Canadian players in the AI and IoT space. And the objective is to make everyone aware who they are so they can connect and partner together or sell products to each other. We are also looking at a national AIoT strategy. And the whole point there is to advocate for the AIoT ecosystem, which we are forming, strengthen the ecosystem's cohesion, bring members closer together, understand their needs, and express that in a report, and also drive government industry policies. Our operation is primarily performed by volunteers such as myself and Sal that's on the bridge and some other people. We are funded primarily by membership fees, and that money goes to pay some external expenses and essential professional services. But we do rely on people volunteering their time to help out. And we are a nonprofit organization. So appreciate any help you can provide us in terms of volunteering to do certain things like marketing or help out at the conference or help out at the networking events. A little more detail on the IoT Spring Summit. Here is the agenda. You'll see it's a packed agenda. It runs from 1 o'clock to 9 o'clock and has presentations on AI and IoT hardware technologies, a couple of interesting panels. We'll have a sit-down served plated dinner along with a fireside chat with a prominent government minister. And following that, we'll have a roundtable around Canadian AIoT opportunities, challenges that the audience can actually participate in and pose questions, but not only pose questions, provide their own opinions about different topics. Just a quick note, we published a white paper a few weeks ago. It's out there. You can find it at this URL. And if when you do look through it, we would appreciate some feedback. You can go back to the same page and click on the feedback button and provide your feedback on the white paper and the tenets that it proposes. So with that, I'll introduce our speaker today. Speaker is Umair Sadiq. He is the co-founder and CEO of ReasonX Labs, and I'll let him explain what ReasonX Labs does. He has an over a decade of experience in design and deployment of safety critical autonomous systems. A lot of experience that includes special projects groups participation at Apple, Box Research and Technology Center, and QNX, no doubt here in Ottawa. He has a PhD in formal methods and a research fellow formerly that investigated the intersection of formal methods and cybersecurity. So with that, I will hand it over to Umair. Take it over.
Thank you, Walter and AIoT Canada team for inviting me for this talk. Let's get started. Let me share my screen. Can you guys see my screen?
Yes.
Okay, perfect. Like Walter mentioned, I will be talking about safety assurance of AI-based systems, and not only challenges, but we will also a little bit talk about the way forward. Let's get started. So this is very high-level agenda that I'm going to cover, which essentially includes AI safety. We have some real-world examples. Just look at them. You know what is the real problem here, and then relating AI safety to safety engineering, which is been there for a long time. And then what are the proposed solutions, and then some call to action, some in general, and then some very specific to Canada. So a future with AI-powered systems seems to be, closer than ever. And last 10 years, we have seen a wave of, technological innovations, both in hardware as well as in software, and now more recently in AI-based software stack. So you can think of these, applications ranging from mobile robots. These robots, work along with workers in warehouse settings and hospitals. And now recently, humanoid, because they are much more general purpose form factor, but can be used in limited applications, ranging from, domestic applications to some applications where mobile robot may not work. And then, we have autonomous cars ranging from, fully autonomous cars to, partially autonomous cars. We have seen that in last 10 years. Still, there is a lot of progress, and then a lot of progress is required to make this technology successful. Other applications, drone delivery, smart machines, surgical robots. We are talking about rehab robots powered by AI. And we should also think of it as AI agents, which are software-based entity again run on a hardware, but a software entity, which is, AI agent, and then controlling some safety and mission critical application. So this is a general landscape, and this is really fueled by the opportunities in terms of, economic opportunities, and then, the performance and efficiency that would bring to communities. That's kind of, the thesis behind this innovation and this kind of, boom right now. But if we notice in here, this technology really interacts with human, and it has to, work in areas, or, do a job in some places where it would directly interact with human. It could be child, it could be, worker in the factory. So when such a situation happens, of course, there would be some sort of trustworthiness that we would be looking for. Uh, let's take an example. What happens when such a technology fails? Uh, can someone mute his mic? Okay, so this is an example of a chess playing robot broke the finger of 7 years old in Russia. So this looks like a friendly robot and friendly match between a robot and a child. But the problem was that robot could not recognize the difference between chessman and child's finger. And this is exactly the situation we are talking about, that when such a technology is out, without some sort of assurance and some sort of check in terms of is it safe to be there, because there are two problems with such incidents. One, public trust hinges on this technology to work trustworthy, in a trustworthy fashion. If these incidents happen, we lose public trust. And again, the previous slide we talked about, we are going to bring all this technology for public, but if public loses trust, then means it is going to delay its time to market, and then because we need to do a lot of many things. So this is one example, but let's look at another example. This is a funny example, but again it would become critical eventually. So now we are talking about the coffee machines powered by AI, and of course this would help people, but we already know that if this coffee machine is going to mix a caffeine and some other things and all sorts of flavors, I mean, we know that caffeine overdose also has so many issues. The same thing, vending machines where Coca-Cola is going to be mixed by AI. Again, how much caffeine you add, it's going to be, impacting some way. So it looks like we want to bring AI into everything, but then we also have to figure it out where it is safe to do so and where it is not safe to do so, and then what needs to be done to make it safe. For example, in this case, it's much easier to safeguard it, but I'm putting it in here to just, give an example. When such technology will come into our lives, we'll have to make sure it's safe. Let's look at some other examples. AI powered robots can be, jailbreak in maybe 20 prompts. This is the work from US University. They actually jailbreak almost all available LLMs at that time. So if we are going to power these robots, and with AI, so it would be much more easier to exploit them. And over time, the companies are improving their technology, how we can jailbreak or how we cannot, and they are putting all sorts of safeguards. But still, once such a technology is available as a part of physical system, then we have to make sure that we put proper safeguards. And for that, again, we will be looking into next slides at what needs to be done. A couple of months ago, I was in France in this inaugural Safe and Ethical AI conference, and their Hugging Face, they mentioned about this paper, where their thesis is that fully autonomous AI agents should not be developed. And why they are talking about this, it is actually a combination of what those agents can do. So you have a basic level agent, they just do a simple task. You have, more sophisticated agent. They can, just call some things in your, for example, in your computer. But then you have a fully autonomous agents. They can replicate themselves. They can write code. They can, do all sorts of things. So they are pretty hard to control. So the question that we should ask, do we need fully autonomous agents right now, or we don't? Because 99% of the things that we want to do, can be done with other level of autonomy through those agents. So that's why they are, uh, you know, uh, putting out this in the world to, have more candid discussions when we want the fully autonomous agent. And before we bring full autonomy into agents or, the artificial general intelligence, do we need some sort of regulations before? So this is kind of a quagmire right now people are talking about. But in here, again, we should think about these AI agents with different level of autonomy. As the autonomy is increasing, the risk is also increasing. So we talked about safety, but let's look at safety from safety engineering point of view. Safety engineering has been there, so we are using our cars, we are using all sorts of other safety critical technologies, and they work most of the time. We don't see cars braking every day on on freeways. So, what is really the definition, and then how critically, and then how conservatively the safety standards look at this technology? So, let's start with the safety. In general, it's an absence of unreasonable risk due to hazards. One important thing in here is that unreasonable is not a term that we can identify universally. Unreasonable changes from one community to the other community, one country to the other country. So this unreasonable risk is actually defined by the people or the governments. So once we have this safety, we talked about two important terms. One is risk and hazard. And hazard is essentially a potential source of harm. And what do we really mean by harm in here? It's physical injury or damage to health. So this is how safety engineering standards are looking at things. But if we just expand the scope, AI safety is talking about everything. AI agents taking over the governments, the rogue AI agents and, AI agents wars, AI race, everything, privacy, you can think of security, everything is plugged into AI safety. That's why it is hard to comprehend also. In terms of safety engineering, we are also, even worried about when you open the door of your car, are you going to have some pinch or crush? So the scope is that narrow, but when we talk about AI safety, then we are just including every single thing in there. So this is a risk taxonomy from MIT. Really, really useful database. If you haven't looked at it, just search and then look at it. They have very nice categorization. So in AI safety, we are talking about ethics, and then these different colors are showing different time kind of grouping. We are talking about the privacy. We are talking about the biases. We are talking about cyber attacks and material footprints, environmental for example, pollution and environmental harm. We're talking about the reliability issues and transparency. So a lot of things plugged into the AI safety. The point that I want to make here is even for safety standardization in specific type of embedded system, let's say in automotive, the focus was really narrow and still people are having a hard time to follow those standards to make those systems, comply to those standards. Now, in here in AI safety, this is an explosion of terms and the things that we have to do. And right now, there is no kind of a direction, which direction we need to go, which type of analysis you need to do, what is really required. And there are some standardization efforts, and then I will talk about it in a bit in coming up slides. Now, let's talk about the safety assurance gap. Uh, right now, if we are not thinking about so much AI into our systems, we are still lacking behind in safety. So, but with AI powered tech, it would grow exponentially. We have breakthroughs in hardware. We are talking about all sophisticated hardware. Yesterday, NVIDIA announced new chips, and every other company, Amazon, Google, Microsoft, they are building their own chips too. So AI powered systems, which is combination of AI based algorithms as well as hardware, and together we can call them hard tech, is going to grow exponentially in terms of what they can do. And safety assurance is always catching up behind. So what happens in such scenarios? At minimum, we lose money. How? Because you deployed something, it didn't work fine. We had some incidents like the robot that I mentioned. And then what would you do? You would do a recall, and recalls are expensive. Just look at automotive recalls and how much money is spent on that. And then if those things happen multiple times, then you lose, lose the public trust as well as you have a loss of brand reputation. And we know the cruise example, we know the Uber, ATG example in Arizona. And in worst case, if these things will be overlooked, it's about human lives. Someone can get injured, someone can, die. So that's kind of, the scope of the gap and then its corresponding implications. So we have to do something where we just do not make this safety assurance line as a flat line, but try to catch up with AI powered system. It's not only the technology is moving fast, but we also as a safety community also come up with some frameworks which are faster than the way we do things now. So I think I did a lot of fear mongering, um, a lot of all the bad stuff, all the problems. But again, let's revisit what is really the grand scheme in here. So AI has a great potential to assist us. Everyone agrees. AI safety is important and unsolved. But the question is that did we hit a dead end? What are we going to do? But I strongly believe there are ways to move forward, and let's talk about them. What are those ways to move forward? So potentially, I'm categorizing them in two broader uh, areas. One is safety cases, and the second one is safeguarded AI. One part is where you build something, but you also build an argument why such a technology is safe. You try to prove it the way you just go and then prove something. You will structure your argument. Yeah, my AI system is safe. Why it is safe? Because I followed standard. I followed standard. I did testing. I, did by design. We put the runtime guards in there. You just structure all your argument into one holistic document that can become your evidence why you can deploy it. The other part is safeguarded AI. This is essentially ensuring the mathematical correctness of your AI models at design time, but also at runtime. Every output coming out of your AI system should be safe with respect to its environment and its requirement. And we'll look at it in a bit. So these approaches are still in its infancy. They are just starting to, get traction. And if you are a researcher and you are a student, and you are an engineer, now is the right time to contribute. And that's what we are doing at ReasonX. So classical safety engineering lifecycle. So if you have a system that you want to deploy somewhere, you would essentially would have some potential requirement. For example, if you want to deploy a robot in a warehouse setting, you know that what needs to be done. And then depending on where you are deploying, is it in US? Is it in a particular state in US? Is it in Canada? Is it in particular province in Canada? The same thing for Europe, Japan, and other part of Asia. Then we will have the regulatory requirements, and regulatory requirements would, provide you high level guidance, what needs to be done. How do you follow those regulatory requirements is essentially using the best practices. And those best practices are written in standards, essentially ISOs, IEEE, IEC, ANSI, and OSHA. Once you have done all that work, you will go to a certification body to where you probably have seen these labels in elevators, but the other systems also have. And then you get certified. This certification usually 3 to 4 years, and then in previous times, 10 years ago, that was the case. You get certified, you put your product out, and then you get this certification after a few years. But now the systems that we are talking about, they are not washing machines where we are not going to do software update. By the way, there are washing machines right now, they get the over-the-air update. But we are talking about the systems where we are going to upgrade the software every week or every month because they are learning. So that's why we have to build a continuous safety assurance case. It's not a one-time done and dusted deal. So you have to continuously make sure that things would work. So again, from safety engineering point of view, this is how the analysis starts. The core concept here is called safety integrity level. So essentially what you are trying to figure it out is what is the task which would be done by the AI? Is it going to be, doing task X, pick up some objects, just move things around or, drive someone from point A to point B? And based on that task, you will do the risk assessment. And risk assessment is a combination of what can go bad, what is the operational situation, what are the actors involved, and then you map it to in this kind of beautiful graph. This looks beautiful, but very difficult to map. In some cases, let's say I have an AI system. It has a problem. It doesn't start in the morning. That's okay. It's an acceptable risk because nothing will happen because it's not moving anyways. But if it starts spinning in the morning and then it's a domestic application, it can start, hitting people around it. Then we will put it, in the zone of yellow or orange to red, depending on what can it do. So once you figured it out, what is the severity scale in here, then standards will tell you what needs to be done. What is your development process? How good your software have to be? How reliable your hardware has to be? How you are going to avoid systematic failures? Then there are some, strict targets. For example, for our steering assist system, it's, they are designed to high reliability, where, 10 failures per 1 billion device hours are the acceptable criteria. That's why if you see on road, we have millions of cars, but, the steering system is working fine because they are designed to really, really high reliability. They do fail sometime, but that's, that is the part of the recalls and that. But in here, so we should have similar framework, but also build a dynamic safety case. This is just a picture how people are building right now the engineering systems, which are pretty complicated already. So let's look into the safety case. So I mentioned briefly that how people structure safety case. There are so many ways of doing it. You can just write in the form of paragraphs. You can structure it in some notation. I'm using a notation called goal structure notation. So you start with a goal. You say that my AI is safe to deploy. Then you put up some strategies to back this goal up. So you'll say that, okay, we have strategy A, B, and C. And then from the strategies, you will have more sub goals. And then you will go down to your design and your testing and all the things that you have done. So again, it would be very similar. For example, LLM agent does not pose an acceptable risk. You say that, okay, we actually figured it out all the risks. And then we are going to do, protect our data and protect the training data. And we are going to protect all the weights. And then, at the end, your solution is that probability of an LLM agent doing something bad is going to be less than 1%. So that's the guarantees that you are providing. But when I talk about the dynamic safety cases, that's not a static guarantee anymore because now your thing is your system is in the field and you are getting a real data back. So you have to plug it back and then figure it out. Do you have potential to violate this assumption? Because that was the assumption based on you were allowed to deploy something. And how does this work? So there is a lot of work from UK AI safety, but now they are calling themselves AI Security Institute. So what happens? So writer in here is that a company, let's say OpenAI or Anthropic or other company. So they will build a safety case internally. They will send it to red team, and then red team will try to break their safety case. Oh, actually, I can fool your LLM in X, Y ways and Y, and they will try to improve their filtering. Once it's done, then you can send it to decision maker and then they make an approval. They said that, yeah, actually, we believe your LLM or your model is, good to be used in XYZ applications. But there are some other, extensions to it where, you have, frontier AI company and then, those decision makers and red teaming could be, regulatory bodies themselves. So rather than internal, but you also have an external body testing your system. And decision makers could be, governmental or regulatory body. Again, there are a lot of variations to that. There is no acceptable way of doing it, but this is one way of doing it and has some potential to improve on. So all in all, what will happen for a given AI model, you will build so many modules. So this is the kind of a modular safety case in here. So you'll say that deployment safe. Then you'll say that control safe means that there is no inability that we cannot control it. So you are going to argue that okay, it is controllable, my model. And then you will say that I'm going to use approach A, B, and C. Then you will talk about the alignment safety case, security safety case, and then this list goes on. All the things that I showed you in that beautiful graph in the starting slide, you'll say that the privacy and then biases and all those things. And then each one of this box actually contains a dedicated safety case inside. And there is a lot of traction about this. Companies are using it. If you go search about safety case Anthropic or safety case Google DeepMind, you will find some things on their web. Now, this is the second approach, which is safeguarded AI. Um, it's a it's a very bold statement from you can see a name known people in here who are talking about Max Tegmark, Sanjeet, Yoshua Benju. So there are big names putting up this paper. I think last year, 1.5 year ago, they are talking about we should not deploy anything until we can prove it's safe and prove it's not by words, by mathematical guarantees. And of course, there is a lot of sentiment about this approach. Again, within computer science and and physics and AI community, but I still see a lot of merit in it. But people are just taking it out of context and not fully understanding what is the purpose of this in here. So, how does this work? So, according to this approach, you should have a word model and you should have your safety specification. So, word model is essentially all the state space of your robot, what it can do in the word, and then also the state space about the word, how it can change. For example, if it's a classroom setting, students comes in, student goes in, how fast student moves, all those things. So it's kind of infinite state space. But somehow you abstracted it out, and then you have a word model and you have a safety specification. And then you have a verifier. And then in that verifier, what it does is that whatever your AI is putting output, this verifier is giving you a runtime guarantee. And this is really opposed to the approach which is happening right now, where you have an AI model, you do some sort of testing, and then that's it. You say that my testing is good, and then I'm going to deploy it. But on the other hand, on left side, we are talking about this verifier part of the system, or it's kind of a digital twin, or it could be anything, but you have real-time guarantees that whatever is coming out of your AI agent is actually safe with respect to the word model and safety specification. We'll look at it in a little bit more details. So this is a current practice. What happens is that let's take the example of ChatGPT in here. So we built a ChatGPT, which is a frontier model, and how it's being tested. So you start asking some questions, try to jailbreak it. You said that, okay, this question, that question. If it is Chinese model, you'll talk about China, it will not answer anything. If it's a US based model, you talk about President Obama will not say anything. Or, the other things, all the harmful content. It's kind of a laundry list of things that you don't want your LLM to respond to or to that effect. So you do a lot of testing. Let's say you had hundreds of those questions. And then if your LLM agent passed, some percent, you said that, okay, it's good, then ship it because residual of this chatbot to, say something bad or do something bad is extremely low and then you ship it. But in here, there is no guarantee it's not going to be. People are not, I mean, the people who are testing do not have all the smartness in the world. So there are other smart people out. They will misuse it and they will use it. And that's what happened in the last 5 years. Every time there is a model, people do jailbreak it and very, very quickly. Second option is that now you're not relying on testing by the tester. Now you have a red teaming. Now red teaming, it's a group of brilliant minds of their, within their field. And now these are highly skilled users. They know how the model is trained. They know all the ways it can break. They will do all sorts of fault injection and then try to break your model. Now, again, I think you did a little bit better job than the first approach, but everything is based on the skill of these red teaming people. Did you get it's again how brilliant these were, how brilliant that group was. All your safety case rests on their brilliance. The guaranteed safety says that no matter what, now we are here, there are two universal quantifiers in here for all contexts and for all input, your word model. Your trajectory is safe no matter what. It's not matter of, some sort of that, okay, you passed X number. You are doing it at runtime. So that's the part where people have a lot of criticism about this approach. But again, there are a lot of merits to it also. What will happen even if we cannot do this third approach? Just following or trying to do it will already, improve our models and our safety cases. And just call to action. This is specific to Canada. In UK, there is a lot of investment. And then if you look at, their UK AI Safety Institute, or now it's a Security Institute, they, according to their report, there are going to be 524, like around 500 firms, working in about, safety and AI tools and stuff like that. And there is, 12,000 people employment. It's huge. And Canada also has to, work on it. Um, there are work being done, but I think that can be done in even a larger scale. So I think I put together quite a few things, but now maybe some of you would be thinking, what about standard? Is that such a bad idea? Why didn't I talk about the standards and what is happening in that space? Um, I'm going to talk about it, and then I know about standards. I also spent a lot of time in contributing to standards, but I kept it to this moment, and then we'll talk about it now. Um, One thing that I want to mention with respect to AI standards, so there is this AI Standards Hub by UK again. I think it's a consortium for different countries. If you have not checked it, just go create your account and then go check out, AI Standards Hub. There you can go and then, you can and probably search almost all standards. And the important thing here that I want you guys to note is there are kind of 300 plus standards, and you can think of, how hard it is to follow all those standards. Uh, but all in all, let's look at this with an example. So this is my favorite example, being part of standardization and being guilty of this also. So this scenario is that there was an engineer. He sent a message to one, in every company, there is a guy who is pro in standards. So he asked him, what are you working on? He said that we are writing a standard number 11, which is actually a combination or, summary of the other 10 standards. And now we are going to have 11 standards that we have to comply, not 10. And this happens so often and very frustrating. And then this guy didn't stop. He said that don't worry, we will write another one to do the conformity assessment of all 11. So then you have 12 standards. So that's how things work in standardization. Sometimes we have a lot of standards. Some communities, for example, I would say automotive functional safety, they did a great job as compared to industrial automation, where the scope is huge and standards the landscape is also huge. It's not very easy to navigate. So the question is that when people think about and listen, when they hear about standards, is this really a bad idea? Actually, there is a lot of misconception. Some people, when we talk about AI safety standard, they think someone is going to tell me how to train my model. That's not the case. There are standards and they have to be at three different levels. I'm adapting this from industrial machinery domain. So there are different levels of standard, type A, type B, and type C. So generally, this is my proposal. Type A standards, they just talk about the general principles about some technology. Okay, what is AI safety? What are associated hazards? And how we do hazard and risk analysis. Nothing about technology. But right now, I showed you this big, landscape of terms. No one knows how to do it. There is no universality into that. Everyone can do in different ways. So the first would be a type A standard says that, okay, what is AI safety? What are hazards associated with it? How do you do hazard and risk analysis? Then you have type B standards, which explicitly talk about a general approach. For example, if you want to make a security case or an inability argument, and then what are the requirements around that? And then you have type C standard, which goes and complement type B and type A standard by explicitly giving you a prescribed list of things that you need to do. For example, how would you actually train a model? When we talk about standards, we don't talk about type C standards. So type C standards would come probably in 5 or 10 years because you write type C standard when there is a universal consensus about a technology. For example, right now there is a USB-C standard. Is there any confusion about it? It is USB-C. It is not going to change. But we could not write it maybe 30 years ago. The same thing with other IEEE standards. So once technology is mature, widely accepted and understood, then you write type C standard. But right now, the need is to write type A and type B standard But this taxonomy or this analogy doesn't exist in AI safety community right now because we just want to write documents. And that's why we have 300 plus documents and navigating them is another pain. So another call to action, I strongly believe with AI applications, we cannot follow a traditional loop. What happens? Research, prototype, deploy, learn, improve, and then best practice. But right now, there is no time to do so much research and so much prototype because right now people build and deploy because that's how fast it is. And we should have a dedicated stream of safety cases and safeguarded AI in KC. And then we are talking to NRC and Canadian AI Safety Institute to propose that. Um, and then again, our ReasonX assurance platform also include the how you actually build safety assurance cases, and it's free for nonprofit and universities, and even for specific industries. If you want to use it, just get in touch, and we can provide you the access to how to build continuous safety case. All in all, that's my last slide. I think safety assurance is a team sport. It's not one man's job. So you have to actually, uh, you know, it's not one person job. So you have to, work together, academia, government, standardization, all other hardware technologies, AI, ML tech, and non-profit, consortiums. So all of them have to work together to come up with something so we can make this technology safer and use it to our advantage. Uh, Thank you so much. If there are any questions, happy to answer them.
Yeah, thank you very much, Mayor. I found it very fascinating, especially when you talked about specific examples. Intuitively, one can understand or suppose that AI safety is important, but when you actually set out certain example, it shows how critical it is. Like for example, with the chess and the child's
Yep.
fingers. Okay, so if you have a question, please put it in the chat, or at least indicate that you have a question. But in the meantime, I do have some questions myself.
Sure.
Um, I'm just wondering if you could elaborate on where you draw the line between actual AI safety versus uh, misinformation that AI puts out, like in ChatGPT, for example. Right?
Yeah.
You ask it a question and gives you some answer. Some of it may not be correct, or some of it may be not answers, like in DeepSeek. If you ask about Tiananmen Square, they doesn't really. I hear
Yeah.
that it doesn't give you an answer, right? So is that a safety issue, or is there something deeper that you categorize safety?
So right now in AI safety community, everything is safety. Even
Yeah.
false information is safety. Sentiment search is also safety. But traditional safety engineering take it differently. So like I mentioned, this is the core of the definition in here. Where did it go? Yeah, this. So for safety, absence of unreasonable risk due to hazard. Now, how do you define the risk is the thing. For me, I strongly believe we should we should categorize it in different ways. So I think one big pillar would be ethics, misinformation and alignment and the other things. And then, still we can categorize it as a safety, but the traditional sense safety should be about physical harm
Mhm.
in one way or the other,
Right.
because otherwise it's we are not going to solve this problem. We cannot write one standard talking about all those things, and then when we will have 30 standards, then good luck.
Okay, thanks. So Andrew has a question. Would you be okay with us forwarding this presentation? I am thinking that deans of ACCE and SAT at Algonquin College and the 624431-6 committee. Is that a question for me, or is that a question for Omer, Andrew? You can unmute and ask your question.
Yeah, either one. That's just I'm just thinking that all of this topic is would be relevant to the committee because it's it's about risk and AI, but which is usually part of IIoT in this at this time, and uh, and just to spread this around to the community over at Algonquin in terms of the technology at both levels. So it's either person who.
Okay, so
Yeah,
I'll let Umair your chart so you can say whether or not that can be
yeah,
covered.
absolutely. I can share a condensed version of this presentation, and there is nothing proprietary in this one. So I would be very happy actually if you will circulate this, and then also happy to talk about at different. If required, I can go present again, but I can share the slides. It's fine.
Oh, that'd be great. Thank you very much. I appreciate that.
Just to elaborate on your question, Andrew, you use an acronym there, ACCE and SAT. Can you
Oh, right.
just
Sorry. Yeah,
quickly
acronyms.
say what that is?
Yeah. So that's the Algonquin College Center of Construction Excellence. That's that building
Right.
on the west side of Woodruff, and then SAT is the School of Advanced Technology. So um,
Yep.
the funny thing is that the IoT and those kind of things are not only in SAT, but we do have some of that in ACE because we also have building science, building automation, and all kind of stuff. Yeah,
Yeah, absolutely. I will provide you the slides.
perfect.
Okay,
Thank you very
perfect.
much.
Do we have other questions from the attendees? Okay, I do have a question. I asked you this question before we started, but the rest of the people weren't here to hear it. Just if you could comment on where Canada stands, how does it compare to other countries in AI adoption in general, but more specifically on AI safety, innovation and standards and regulation.
Yeah, so in general, I think in terms of general standardization and regulation, I think Canada I would rank them really, really high after Europe. Um, and then in terms of AI safety, I think UK AI Safety Institute, they are taking the lead in some of those things. But I think in terms of research in AI itself, and now, starting to begin with AI safety, I think Canada has always been leader in there. And with the Canadian AI Safety Institute, I think this is also a great step. I heard about NRC also building something about, dedicated, department for AI safety. All good things. My only suggestion is to also involve, industry from the start rather than make it too much of an academic activity.
Okay. Also, kind of dawned on me that we're trying to assure AI safety, and the question I would have is, can you use AI to actually help with assessing and uh, and implementing AI safety itself? Like use the
And
tools.
yeah, this is I think a great question, and every safety engineer is thinking about it because AI has a lot of potential to automate so much of a boring stuff. And but this is kind of a paradox, right? In the start, I said that AI is doing all the bad things, and then I come up with the solution which also relies on AI. So potentially there is a ways of doing it, but again, when you build such tools, you go and then do the qualification. It totally depends what that AI is doing. Is it something that human can actually check it or no? For example, the task at hand is just, for example, it's a checklisting. Is there this term exist or this document exists? But if AI is doing much more sophisticated tasks, then human cannot go and then, recheck it in one way or the other. Then, we are again at the same, we are at the mercy of that AI that we use to do the compliance or the check also. So again, this is something on open, not talk too much about, but every AI safety assurance or tooling would benefit from the AI. But then we have to categorize it. What purpose did we use? And then can we actually double check and stuff like that?
Now, you talked about in one chart. You talked about the gap between AI rollout and adoption. The speed of that versus uh, handling issues of safety and regulation. There's a gap between.
Yep.
It's kind of a diagonal, right?
Yep.
AI adoption goes like this, right?
Yeah.
Fast. and regulation goes tick, 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 very slow. So I'm just wondering if you have any opinions about how we can narrow that gap.
I think the regulations would so regulation is one thing where, for example, regulation would tell us that build a safer technology. And there is nothing wrong about that. I mean, we should actually have some sort of regulation so people start thinking about it. Standardization is another thing where you start talking about how you do it. But I think regulation should be done and should be, carefully crafted that, okay, it doesn't stop innovation. And I believe it will not stop innovation. It will explicitly say that, okay, what needs to be done and the burden of proof is on the way you are doing. And then, of course, standardization will come along the way. But what I strongly believe is the safety assurance should not be thought of as a separate activity. So your safety should be a byproduct of your good engineering practice. So that's what we need to, promote. You should build tools and infrastructure that along the way, for example, if you have a better way of doing hazard and risk analysis, that you can do it in few hours, every company would start doing it. But when we go and tell them, oh, you have a, spreadsheet with 3,500 lines, it's kind of a turn off. So my proposal is that we should also improve the way we do the safety analysis so that actually it get tightly integrated in the the design life cycle itself.
Yeah, I guess when it comes to AI rollout and safety, the fundamental way of doing it doesn't really change from other types of products. Whether you're
So
building a bridge or whatever, you build it with safety in mind, with all the infrastructure needed, rather than test it at the end and see if the bridge fails, right? Or same thing with cybersecurity.
yeah, exactly. It did work in case of websites, but all those websites companies are doing now AI safety. But in the websites, you have a safe state, you just restart it. But with AI safety used in some critical technology, the restart is not a safe state.
Okay, so if you have any additional questions, the audience, please unmute yourself and ask the question now before I wrap up. Okay, I do have one last question, and that is there anything that the AIoT community, the association, uh, can do to assist ReasonX in your development or innovation? Whether it's beta testing, whether it's input on requirements. Is there anything like that that you could help with?
Yeah, absolutely. So our platform is up and running and ready, and we are piloting with different companies. So we would be very happy to if people who are interacting with all the companies, and we have a really nice program where we only not only deploy our platform but also help for a few weeks to start getting into it, and we also provide the trainings and everything. So we would be very happy if from AIoT platform we can get some users.
Okay, and to engage you on that, they go to your website and there's
So we are very much stealth mode. So we are
okay.
not putting exactly what we are doing, but I think in few weeks we will be more public. But in the meantime, I can share specific slides and information that you can share with your partners.
That would be great. Okay, so actually, there's one more question from Andrew. Does the complexity of the system pose issues for testing? How do you test for emergent behavior?
Yeah, absolutely. I mean, the testing is a function of how complex your system is. For emergent behavior, that's the idea is that you cannot test before deployment. You have to continuously testing. That's why you have to have some runtime guard into that until and unless you have some quantum computer to enumerate all the future states and then test it. So that's why the idea of runtime assurance is paramount in that case. So you actually make some runtime safeguards.
Great, thank you.
That's great. So, Mayor, thank you very much for this very insightful presentation. We will be putting it up on YouTube, and I'm sure we'll get lots of views of that. And really appreciate the time you took to prepare and to deliver this event for us. Well, thanks
Thank you
again,
so much.
and thanks for everyone for coming. today, and stay tuned for announcement of the next webinar. Take care.
And thank you so much. Thank you. Bye.
Bye.
Bye.